Hey everyone, welcome back. Ready for another deck dive?
Definitely.
Awesome. So you guys sent in a ton of stuff on fingerprinting. Really cool stuff.
Yeah.
Yeah. And one thing that I thought was super interesting, everybody knows about dusting for prints, right?
Right.
But superglue fuming, that's where things get really wild.
Oh, yeah. Superglue.
Yeah. So it's used on like tricky surfaces, glass or metal, that kind of thing.
Mm-hmm.
And the standard procedure, you have to heat the superglue to 120 degrees C.
Oh, wow.
But why that temperature?
Yeah.
Some of the research that you sent actually questions that standard. Like, is that really the best way to do it?
Interesting.
So to help us unpack all of this, we've got an expert in all things forensics.
Hello.
Welcome to the deep dive.
Thanks for having me. I'm excited to talk about this. It's a really cool topic, and there's more to this 120 degrees C thing than you might think.
Absolutely. And one of the articles you sent, it mentioned that this has been around, superglue fuming has been around since the 1970s.
Yeah. Wow. That's a while.
Yeah, it is. And some of the early techniques, they sound almost DIY.
Oh, really? Like what?
Like they were heating metal blocks to do this, or even using a light bulb.
A light bulb.
Yeah.
Yeah.
Can you imagine that in a modern lab?
I mean, it's kind of amazing they even figured that out.
That is amazing.
Back then.
Yeah.
Yeah, it really shows you how far things have come. But basically, superglue fuming, it all relies on this ingredient, cyanoacrylate.
Right.
That's the main ingredient in the superglue.
Mm-hmm.
And it reacts with moisture and other compounds that are in fingerprint residue.
Okay.
And this reaction, it creates a white polymer.
Mm-hmm.
And it's essentially like a fingerprint sculpture.
Oh, wow.
Yeah,
So it's
yeah.
like building a tiny, super detailed model of the fingerprint.
Exactly.
That's so cool.
Yeah.
The sources also mentioned that humidity plays a huge role.
Oh, yeah, for sure.
Like around 80% is ideal.
That's right.
Why is humidity so important in this?
Well, it kind of acts like a catalyst, it gets the reaction going.
Okay.
And it also affects how the polymer forms, the structure of it.
Oh, interesting.
Yeah, the humidity's too low, the reaction might not work so well.
Right.
And if it's too high, you end up with this like messy polymer structure.
So it's got to be just right.
Yeah, you need that sweet spot.
Yeah.
And when it is just right, you get what they call a noodle-like polymer.
Noodle-like polymer?
Yeah, which means, it was a good reaction and you'll get a clear fingerprint.
Wow, noodle-like polymer. I'm going to have to remember that one.
Yeah.
Okay, so we've got to have the right humidity, but let's get back to that temperature puzzle.
Okay.
You sent this French gendarmerie study, and it really caught my attention. Apparently, they were getting ready for an audit, right?
Yeah, they were.
And the auditor, who wasn't even a fingerprint expert, asked about this 120 degrees C standard.
Just curious.
Yeah.
Just why this temperature?
And the lab didn't have a good answer.
Huh.
Which is kind of crazy, right?
Yeah, I guess so.
But anyway, so that led them to do this whole research project.
Wow, just from one question.
Yeah.
That's cool.
So they tested a range of temperatures from 50 degrees C all the way up to 180 degrees C.
Okay.
And they compared those to the standard 120 degrees C.
Hmm.
They used all different surfaces like glass, metal, acetate sheets.
Wow, they really went all out.
Yeah, they did. And they even tested fingerprints of different ages, like how old the fingerprint was.
That makes sense.
Yeah.
To be thorough.
Talk about thorough.
Yeah.
They also had 3 different fingerprint experts.
Oh, wow.
Yeah, to evaluate how good the prints were,
Okay.
looking at things like clarity, detail, and background noise.
That's interesting.
So what did they find? Was 120 degrees C the magic number?
Well, that's where it gets interesting.
Okay.
So temperatures below 120, they always ended up with prints that were, less visible and less detailed.
Okay.
But here's the surprise. 150 degrees C,
Mm-hmm.
that's where they got the best results.
What?
Yeah.
Really?
Consistently, across all the different conditions, 150 degrees C gave them the clearest fingerprints.
Wow, that's a big difference.
Yeah, it was a surprise.
So why would a higher temperature work better? What's the science behind that?
Well, one theory is that at lower temperatures, those fumes, they kind of arrive at the fingerprint more slowly.
Okay.
And that might actually mess with the whole polymerization process.
Oh, interesting.
Yeah, and maybe even make it more vulnerable to contamination.
Yeah, that makes sense.
But at higher temperatures, those fumes, they get there quicker.
Okay.
So you get this like faster, stronger polymerization.
Yeah.
Which means clearer prints.
Yeah, that makes sense. But then there's that twist with the 180-degree C test, right?
Oh, right.
That worked amazingly for fresh fingerprints, but not so well for the older ones. Why would that be?
Well, that's where it gets really tricky.
Yeah.
Because at those super high temperatures, the cyanoacrylate itself might start to break down.
Oh, wow.
And plus, a fingerprint, it actually changes chemically as it ages.
Oh, really?
Yeah, so that could affect how it reacts with the fumes. So basically, just like with humidity, there's a sweet spot for temperature too.
Okay.
Not too hot, not too cold.
The Goldilocks zone.
Exactly.
So it's this delicate dance between temperature, humidity, and how old the fingerprint is.
It really is.
But there was one thing that was consistent throughout all of these tests.
Oh, yeah. What's that?
They used a scanning electron microscope to actually look at the polymer structure.
Yeah.
And both the 120 C and the 150 C, they both showed that noodle-like structure.
Right. So even though the temperatures are different, the polymerization process seems to be happening in a similar way.
Yeah, that's pretty wild. It seems like we've only just scratched the surface of what we thought we knew about superglue fuming.
Yeah, it's really fascinating.
But before we go any further, I want to pause for a second and bring our listeners into this conversation.
Yeah, definitely.
What stands out to you guys in all of this? What questions are popping into your head?
Yeah, I'd love to hear what you're thinking.
Right. Because there's still so much to explore. This study just focused on a very specific set of conditions. But, what other things besides temperature and humidity could affect how well superglue fuming works?
Right.
And what kind of experiments would you design to explore this further?
Great questions.
Yeah, keep thinking about that because we're going to dive even deeper into this in part 2.
I can't wait.
Me too. It's going to be good.
Welcome back to our deep dive into fingerprinting. It's amazing how this simple question, why 120 degrees C, has led so many more questions about superglue fuming.
I know, right? It's like we pulled on a loose thread and this whole world of like details is unraveling.
Yeah, exactly.
So one thing that keeps popping up in these sources is the mention of this ISO IE 17025 standard. I know it has something to do with like accreditation for forensic labs.
Yeah.
But what does it actually mean?
Well, it's basically like a quality control seal of approval. Labs that meet this standard, they've shown that they follow all the strict procedures and guidelines to make sure their work is accurate and reliable.
So it's not just about, catching the bad guys. It's about doing it right.
Exactly.
With like real attention to detail.
Yeah, it's like a Michelin star for forensic science.
Oh, okay.
I mean, they're operating at the highest level.
That makes sense that this whole idea of accreditation played a role in that French gendarmerie study.
Oh, yeah, for sure.
Because remember, they were getting ready for an audit.
Right.
And that's what prompted the auditor to ask about the 120 degrees C standard in the first place.
Yeah, those auditors, they're trained to find any inconsistencies or any gaps in a lab's methodology.
Right.
In this case, that one simple question sparked a whole research project.
It did.
That could change how we do superglue fuming.
It's a great example of how even the smallest detail can lead to something huge. Okay, so we've established that accreditation and being super detail oriented are really important.
Yeah.
In forensics. But let's get back to the actual superglue fuming.
Okay.
So what other factors besides temperature and humidity can affect the results?
Well, one really key factor is the age of the fingerprint.
Oh.
So as a fingerprint gets older, its chemical makeup actually changes.
Interesting.
Yeah, and that can affect how it reacts with the cyanoacrylate. It's not super visually obvious, like when a banana ripens or something.
Right.
But those tiny chemical changes can make a big difference in how well the fingerprint develops.
So time is literally of the essence.
Yeah, exactly. The sooner you can process the evidence, the better.
Makes sense.
Yeah.
And then there's the surface itself. Right?
Yeah, the surface is huge.
Superglue fuming, it works best on those non-porous surfaces.
Right, like glass or metal.
Yeah. But it can also be used on semi-porous surfaces.
Mm-hmm. Like painted wood or some plastics. But the trick is that the porosity of the surface, it really affects how well those cyanoacrylate fumes can get in there.
Right.
And interact with the fingerprint residue.
It's like watering a plant.
Oh, yeah.
The soil needs to have the right porosity, right?
Right.
For the water to actually reach the roots.
Exactly.
Too dense and the water can't get through.
Mm-hmm.
But if it's too loose, the water just, runs straight through.
Yeah, that's a good analogy.
Yeah.
The surface is kind of like a gatekeeper. It controls how the fumes and the fingerprint residue interact.
Okay, so confession time. When I first heard about superglue fuming, I just picture sticking a fingerprint in a jar with some superglue and poof, instant fingerprint.
If only it were that easy.
But it's way more complex than that.
Oh yeah, it's a very precise process. And it's definitely evolved over time. So back in the day, they used those heated metal blocks.
Right.
Or even light bulbs. But now most labs, they use these specialized fuming chambers.
Yeah.
And inside those chambers, it's like this perfectly controlled microenvironment.
Exactly. You have to carefully regulate the temperature, the humidity, even how long the fingerprint is exposed to those fumes.
Wow.
Yeah, it's all about finding that perfect balance to get the best fingerprint development. Even a small change can affect the results.
That makes sense why they moved away from the metal blocks and light bulbs.
Yeah,
they just couldn't get that level of control.
Right.
So these fuming chambers, they're kind of like the unsung heroes.
They are.
Of fingerprint analysis.
Yeah, they're working behind the scenes to make sure those results are accurate and reliable.
And speaking of specialized equipment, the sources also mentioned using a scanning electron microscope.
Oh, yeah. That's a cool one.
Yeah, I was wondering about that. What role does that play in all of this?
Well, it basically lets forensic scientists zoom way, way in.
And examine those developed fingerprints at super high magnification. Think of it like a super-powered magnifying glass. They can show you all these tiny details of the fingerprint structure and what it's made of.
So they can actually see those fingerprint noodles, like up close.
Yeah, exactly.
That's amazing.
They can make sure the polymerization process happened correctly and that those noodles have the right shape and texture. It's a really great tool for quality control and analysis.
The level of detail they can see is just like mind-blowing.
It is.
But it's not all about, fancy equipment.
Right.
We also have to think about the human element.
Yeah, definitely.
The sources mentioned that there were like 3 independent fingerprint experts
Yeah.
involved in evaluating the prints in that French study.
Right.
Why is it so important to have multiple experts?
Well, it helps to reduce bias.
Okay.
And make sure the analysis is objective. Each expert brings their own experience and, perspective, which helps create a more balanced and accurate assessment.
So it's kind of like a panel of judges for a talent show.
Oh, yeah.
Each judge has their own preferences and expertise, and by combining all those perspectives, you get a more well-rounded evaluation.
Yeah, that's a great way to put it. And in forensic science, that balance is it's super important for maintaining the integrity of the evidence,
right,
and making sure the outcome is fair and just.
So we've got these carefully controlled procedures, specialized equipment like the fuming chambers, and scanning electron microscopes, and a team of highly trained experts. It's like a symphony of science and technology and human expertise.
It really is.
All working together to solve the puzzle of a crime.
That's a great way to describe it. And the coolest part is we're still learning and getting better all the time.
Yeah.
This research on the temperature for superglue fuming is just one example.
Yeah, totally. Speaking of learning and improving, there was one detail about those early techniques that I was curious about.
Oh, yeah.
Why did they switch from those heated metal blocks and light bulbs to those specialized fuming chambers? Was it just like a convenience thing, or was there more to it?
I think it was a little more than just convenience. Well, those early methods, they worked, but they weren't exactly safe.
Oh, really?
Yeah. The fumes from the superglue, especially when you heat it up, can be really bad to breathe in.
Okay, so it wasn't just about getting the best results, but also keeping the scientists safe.
Exactly. Those specialized fuming chambers, they're designed with safety in mind.
Makes sense.
They usually have these built-in ventilation systems.
Oh.
So they suck those fumes right out and create a safer environment for everyone working in the lab.
Safety and accuracy, 2 birds, 1 stone.
You got it.
Now, there's one more thing I wanted to touch on before we wrap things up. You sent over some info on Lumiciano.
Oh, yeah.
This new kind of superglue that makes fingerprints glow.
It's pretty cool.
It sounds straight out of science fiction. How does that even work?
So it's basically superglue, but it's infused with this luminescent element.
Okay.
So when it reacts with the fingerprint residue, it creates a polymer that glows under UV light.
So no more dusting for prints, just a glow show?
Pretty much. But it's not just a cool trick. It actually has some practical advantages, too.
Oh, yeah. Like what?
Well, for one, it makes the whole process simpler. With traditional superglue fuming, you usually have to add a dye or a stain to make the prints visible.
Okay.
But with Lumiciano, the fingerprints already glow, so you can skip that step.
That's got to be a huge time saver for those busy labs.
Oh, yeah, definitely. And it can also make the prints even clearer. That luminescence really helps highlight even the faintest details, which could be super important for making an accurate ID.
So it's a real game changer then.
Absolutely. It's a big step forward in fingerprint technology.
We've covered a lot of ground today, from the nitty-gritty science to the tech and those amazing experts that make it all happen. But I want to circle back to something we talked about earlier, the role of those fingerprint experts.
Yeah, they're essential.
We have all this amazing technology, but in the end, it's still a human who looks at the evidence and decides if two fingerprints match.
That's right.
It reminds me of those CAPT-CHA tests online,
Uh-huh.
Those distorted letters and images you have to decipher to prove you're not a robot.
Yeah.
Sometimes even I have trouble with those, and I'm definitely human.
Uh-huh, exactly. It really shows you just how incredible our brains are at recognizing patterns.
Yeah.
And fingerprint examiners, they spend years and years training their eyes to spot tiny differences in those ridge patterns and minutia.
Minutia, what is that?
They're like these little details, like ridge endings and bifurcations and dots.
Wow, it sounds like a magic spell.
It does, doesn't it? But those tiny details, they hold the key to identifying someone.
Huh.
Everyone's fingerprints are unique, and those minutias, that's what allows examiners to tell them apart.
Like a secret code hidden in our fingerprints?
Yeah. And these experts, they're the code breakers. But with so much writing on their analysis, how can we be sure they're getting it right?
That's a good question.
Well, that's where accreditation comes in. And ongoing training, it's not just about having a good eye. You need those strict standards and constant learning to make sure your analysis is accurate and reliable.
So it's a huge responsibility.
It is. Their findings can quite literally change the course of someone's life.
That's heavy stuff. And it brings us to a final thought-provoking question for our listeners. Imagine you're a juror in a trial and the prosecution presents fingerprint evidence connecting the defendant to the crime scene. What questions would you ask the fingerprint examiner to be sure you're getting a fair and accurate assessment of that evidence? That's a great question to leave everyone with, because at the end of the day, forensic science is more than just cool gadgets and high-tech labs. It's about searching for the truth and the power of observation and the human element that connects it all.
Couldn't have said it better myself. Yeah. And it's a field that's constantly growing with new discoveries and innovations like Lumiciano pushing the boundaries of what we thought was possible.
Yeah.
It's a really exciting time to be in forensic science.
It really is. And huge thanks to our expert for walking us through this incredible deep dive into the world of fingerprinting.
My pleasure. Always happy to talk about forensics.
And to our listeners, keep those curious minds engaged. Keep asking questions, and who knows what amazing discoveries you'll make. Until next time, happy deep diving.